Yeah, so good morning and good afternoon and good evening, everyone. We have a very global audience with us here today, which we're very, very excited about. And first and foremost, I'm definitely not Tao, but I'll introduce him now in a second. But before we start the actual webinar, we'll just go through a few practical items today. So first and foremost, we're more than 200 registered participants, which means that, of course, we can't have everybody on not muted. That's why we're using WebEx events, which makes all of you muted by default. However, that doesn't mean that you can't interact during the webinar, but you need to ask the questions in the Q&A chat box that you can find to the right there. On the screen. And just remember that there's a difference between the Q&A box and the chat box. So try to use the Q&A system that you see to the right there. The Q&A session will be after the around 40-minute presentation by Tao, where we'll go systematically through the relevant questions. Also note that the webinar is recorded, and we'll distribute that recording both on LinkedIn, also through email, and you also or you can also access it on Whitson Academy. And Whitson Academy is just our online learning platform that you can find on academy.whitson.com, where you can get both access to live virtual courses, live topical webinars such as this, on-demand pre-made courses, and also a lot of tutorials. And the topics that you can find there is typically in the kind of expertise domain of what we do at Whitson, and we try there to cater for all levels, not only call it experts or intermediates, but also beginners. So that's definitely something worth checking out for those of you who find that interesting. The public courses that we offer in 2022 can be found on our webpage under whitson.com/training. There you also find the overview of all our webinars. So we think we already have 10 webinars lined up for this year. That's related also to different topics that we deal with a lot at Whitson. That can be PVT, RTA related items, etc. So you can already register for those webinars that will be held in a very, very similar fashion to what you'll see here today. So my only last job today is to introduce the speaker, a very good friend, Tao Yang, or Dr. Tao Yang, which has both a bachelor's degree in petroleum chemistry and also a PhD in chemical engineering from two different universities in China before he moved to Norway, where he did a lot of work with Curtis Whitson, which is also with us here today, where he did a postdoc at NTNU, and then he worked in Whitson actually for quite a few years before he joined Statoil, or what's now Equinor, where he's a specialist within reservoir technology at Equinor. Worth mentioning for those of you who are active in SBE is that Tao got the International Distinguished Member Award back at ATC a couple of years ago, and that's a picture from that day. And Tao was also so generous to invite me as one of his guests there, so I took a few nice pictures of him, and we had a very, very pleasant time. So on that note, Tao, I'll just leave the floor to you and make you a presenter. And then I'll go ahead and mute myself.
Thank you, Matthias. And now my first job to do is actually put on the screen. I will do that now and put on the full screen mode. Yes, thank you, everybody. Thank you, Whitson, for this opportunity. Actually, this has become a really popular event and with many participants. And today I will go through a relative new thing that if you haven't heard this before, and it's related with the PVT, but it's actually quite early in this what we call the value chain, and it's actually associated with the drilling. When you drill the well, and this technology actually can tell you what kind of gas and oil properties you drill through. Not to the degree as in a PVT lab in the later phase, but give you some really good input for making decisions. Before I show some slides about this technology, I will show you 4 animations we made. So you get a feeling about what we talk about, how this technology can contribute to the real-time well decisions. And this is quite overly simplified, and we're drilling a well into a reservoir. And of course, when you finish the drilling, you need to complete it. And there's currently, especially with all the production well, horizontal drilling, you don't have a lot of data available to make the decision regarding if you're safe in the oil zone or you're actually not. So we want to produce oil. We don't want to produce a gas that we don't need. Okay, and you get the basic data and from the experience and people talk about, so they actually using this overly simplified data acquisition, and you have a chance to get wrong fluid typing. And if this happen that with your well, and this can be something quite seriously, and it's hard to fix. You have to really initiate well intervention if that is actually possible. So that's really challenging. And so what the technology we developed, so give you additional information, and you get a GUR gas oil ratio or the density. You know the kind of fluid you're actually drill through some rather cheap data that collect from the mud gas. And so you actually, before you complete a well, so you know exactly, let me move this screen a little bit down, and you see that we have the gas and oil, and you actually can make a tailor-made decision to avoid the produce the gas. And this is not a simple elimination. It's actually, this is a real case from our field. And this definitely have a lot of business impact for our well placement and completion. And come to another example. Again, we're drilling through the reservoir, and actually we have a bad example this year, and people feel they're drilling into a perfect oil producer, and they start to look at the limited information they have, and they complete the well. And when they start to flow the well, they get a really bad result. So this is something that this technology can really help. That when you have the gas oil ratio, density, fluid typing available when you drill the well, and so you have a chance to regret. So when the well are still available to make some side check, you can actually side check the well and look for the oil. And we are pretty sure from the interpretation that you're in the oil zone, then you complete the well and you produce the oil you're looking for. Okay, so this is another example. As I mentioned to you, these are oversimplified animation, but they're all come from the real field case. And then we start the slides. And the first question is, for many of the audience in this webinar, you know so much about fluid and PVT already. And this is a very just a simple summary. And if you look at the green fonts I use, and this is in a very old time, and people has to work on surface oil and a gas sample, and to find out what is the reservoir oil and the properties. Wireline is the main tool we use today. You can take sample, and you can also make some downhole fluid analyze that while your wireline are placed into the reservoir. And this is the main tool we use, and especially like for the exploration wells. And if you look at the production wells we have, and you don't really have a lot of opportunity to run the wireline. And it's a logging while drilling, and when you get to the several columns of the well log data, and that's what you have. You need to make all the decisions based on that limited information. This is come to the difficult part. During the drilling, we don't have a lot of data here. You have some technologies you can use, like sampling while drilling, and it's very expensive and risky. Your well might stuck, and also you get some not really high quality data there. And so this is the one, like I mentioned in this examination, using the logging while drilling. That's the most people do. They use this one to make a decision. And this is a picture showing this mud gas unit. And I'll come to more details here. This is something like we use the mud gas data as the new fluid source in the drilling phase. And there is two type of mud gas. That the mud gas is when you drill the well, the mud recycle back to the rig or the platform, and then you start to get the gas composition released from the mud. So that's the one. And you have two type of mud gas you can use and to do this type of work like we propose here. And if you don't know and what kind of a mud you're using, if you don't pay anything, then you have the standard one. And if you pay additional fee, and then you get an optional service with a heated degasser, constant volume, constant temperature, with a correction for recycle, and EEC, which is abbreviation for extraction efficiency coefficients. With all of this necessary improvement. So you can get a gas composition from C1 to C5 or close to the PVT sample quality. But you don't really get anything for the oil components. So we have something here that I want to show you that we can use this data to predict the continuous, and it's not like discrete stations. This is the continuous. Every meter you have the reservoir oil and the gas predictions. And I will also cover standard mud gas in the second half of this presentation. So it's more challenging to do the work, but because we have the data for all the wells, and it's actually the business impact is very big for use standard mud gas. And I use a picture from Schlumberger. They're the leading company in the service industry, and they invented advanced mud gas service in 90s. And but you don't have to use Schlumberger and major integrate service providers. They all have something similar. And in addition, you have the independent service providers can also provide mud gas logging. And when this advanced mud gas was invented in 90, and people try quite a long time to use, because of the composition of the advanced mud gas is C1 to C5. They're rather close to the reservoir fluid. So there's always some, initiative try to use this gas composition if we can predict entire reservoir gas or the oil composition. And we're the lucky one that we manage this one and use some advanced data analytics, and as the first one in industry. The reason why it's so difficult to do it, if you look at how we do it in a traditional PVT lab, we have the samples, the live oil or gas samples, we flash it, we get a surface gas, a surface oil. And then we have the GOR, gas oil ratio. We do a recommendation, we know the reservoir fluid, which are consist of thousands or tens of thousands components. And in the advanced mud gas, we have only C1 to C5. And we don't have anything of this. And some providers provide up to C7, C8, but they're without any corrections. You can't really use that data for, they're not close to the reservoir gas and oil samples. So this is why it's difficult. You more or less have a half, maybe less than half data to do this work. So when we start this work, and we did a quite interesting plotting, and we have a internal fluid database with more than 4,000 samples. And geochemists, typically they have a star chart or polygons, no matter how you call it. It's something like this. And this is just example. You can have all the different ratios. This is the GOR gas with a very high GOR, red color. And we use the blue all the way because we want to differentiate the different GOR. So we have all the way down to 100 GOR. These are all metric units. And typically the geochemists, they put into, they look at the certain wells and they have a couple of polygons to look at it. Are they similar with the analog samples or not? When we put this into 4,000 samples into the same chart, you start to see something here. So you start to see that the oil, the low GUR oil especially, they stay in the middle of this polygon. And then the red color, they're very much stay outside. And then you have something in the middle. You do have a general trend, but there is also clearly you can see some outliers. You see some of the blue, they actually jump out all the way to the most outer, polygons. So I will not cover the details. These kind of outliers are generated by the biodegradable oils. And so you can look at this paper and we discuss specifically about these outliers. The important thing is that outlier has to be removed. Otherwise, you can't really start any serious machine learning work. When you have so many outliers, and you know what you get afterwards. Okay, and this is a ski. This is a plot showing how we do the machine learning work. I'm not a data scientist, and I have quite many very talented young engineers. They're working on this, and we follow quite, in a way, standard industry thing. The only thing I want to mention is we tested different machine learning models to find which one is the best to give the minimal prediction error. And we found out the Gaussian process and universal kriging, they give the best result. And at the same time, we find out the random forest, even their result is not the best, but they're rather close. But the stability of the random forest is actually quite good. So we actually use very much the random forest for the predictions. And also I want to mention something about the advanced mud gas quality. It's not, you probably heard from many people, they complain about the noisy data from mud gas logging. And this is true. You don't get something when you get a theoretical, the perfect situation, you get the PVT quality composition. That's what actually you can see from this example. And the red one is advanced mud gas. The black one is a PVT sample. And you have a quite a good data points that they almost overlay. But at the same time, you also get some this kind of sample. And when you have a machine learning model, you try to bring the mud gas in. It's very important to understand that which mud gas data is good, which one is not good enough. So we did quite a lot of work, set up a certain criteria to really make an automatic judgment about the data quality. And this is regarding the accuracies. And the accuracy, the prediction from a gas-oil ratio here is from the PVT samples, but we make the PVT sample, the composition only available for C1 to C5, which is the same as the mud gas data. So with only 5 or 7 components, we have isomers, and you are not expecting you get something close to the PVT samples. Otherwise, our industry practice getting gas and oil, that won't work. So the accuracy we're talking about is about 40% plus minus for the GUR and for the good quality advanced mud gas data. And the red one, they're the outliers. When you have outliers, we don't trust that prediction. So this is a one-page summary, and we did we made a quite decent progress in the company. And before we start this project, and we have 30 wells over 30 years. Averaging is only 1 well for the advanced mud gas, only 1 well per year. And during the project, this 2 years, we run 30 wells. And this year, and the book is overfilled, and we couldn't even support all the wells now. And so this is really something that we're happy to show you. And the main business value are creating through actually the real-time well decisions. They're the well placement, completion, potential side check. These are the main thing. And when people calculate how the drilling and well people are the easiest one to calculate how much money they make and compare with a reservoir engineer. And they can easily come up with a big number regarding the business values. And that really help us also to win different award because people they assign a very big contribution from our technology that make us actually quite visible in a company. This is a summary about the journey we made. And actually, this mud gas thing, we started all the way back in 2014 when I was an expat in the US. And we start from the shale. And that's the easiest part because the fluid in the shale is rather consistent and compared with a conventional reservoir, it's very complicated. And we have idea to actually extend this success from the shale to conventional, and we propose a project to use advanced, basically the machine learning model to help this process. And if you look at this schedule, we didn't spend very much time on the machine learning itself. And after we find out the outliers from the biodegradable fluid, after that is removed, things just goes rather easy. And implementation part, that take time. And especially now we're in a real time. Our data from the service company stream into our real-time trading platform, and people can actually see the prediction already, real time. Okay, I show you two examples before we switch to standard mud gas. This is one of the well that we did, and this is the production well. And most of the oil laying in this layer. This is the top of the layer, and this is the bottom of the layer. Most of the oil laying in this layer. And we have an injector here, and we have a producer from here before, and this is a new producer. And if you look at the 4D seismic, the red color is interpreted as a gas, and you start to see that the gas is overwhelming in this layer. This really worry our people because if this red color is too almost, most of the place already occupied by the gas, and here is a half and a half. It's really not much oil left here, and this is something really they put us into this task. So what we found out from this mud gas is actually because the 4D seismic, their resolution is not that sharp, 20, 30 meter, and this blur interpretation is just not right. It's only 5 meter at the very, very bottom here. They're gas field. All the rest, more than 100 meter, they're just oil field. So we suggest that blocks that 5 meter for production, and then we perforate entire formation, and we get a GOR just in the summer, and it's just as we expected. This is something that the people are really feel very exciting because it gives them so much certainty when they make these important decisions. If you only look at the 4D seismic, you might take a very conservative completion strategy here. The second well is regarding exploration well. And when we look at the advanced mud gas raw data interpretation, we combine with the logging and well drilling data. And we have the gamma, we have the resistivity, and the very important neutron and density separation. And for this well, we have several sand zones with different separation from the density and neutron. And if you've been asked to make a sample, to take a sample and where to take, how many take, this will be without advanced mud gas data, and a decision will be probably taken multiple samples from different sand. And this is the total gas we get from the advanced mud gas. Indicate this is where we have most hydrocarbon. And this is raw data from the advanced mud gas. And this is the quality of the advanced, this is the important thing. And they're all in green, and in a way we trust the prediction of the gas oil ratio. If you look at this one at the different sand, you don't really see some dramatic change actually compared with the separation of density and neutron. So they're all close to 2000. And finally, we decide to take one sample. If you look at this orange dots, this is from where we have the most response of the hydrocarbon. We take one sample, we send to the PPT lab. As you can see, these dots, they measure the GUR, and where this red and blue, that's our prediction. It's rather close. So this is something that will provide a lot of help. Before you run a wire line, you already know what happened, under the ground in the reservoir. Yes, and now I move to this the second topic is about how to utilize standard mud gas. The from the project like we run the day one, we get this question all the time, and people said, "Can you use standard mud gas?" Because the data is free, it's already there. And if you look at what kind of data we have, then you start to have mainly C1, C3. And C4, C5, they're come down to the ppm range. It's really low, and you don't want to trust on that. And most of the standard mud gas data, you don't have a heating. So the heavy component, they stay very much in the mud without coming out. And in our industry, we have some parameters like C1 divided by C2, wetness, Bernard balance, this kind of parameters that used for the to define the fluid type, if it's oil or it's gas. And we in our industry, we very much say, for example, C1 divided by C2 at 12, that's a threshold. And then lower than that is oil, higher than that is gas. And this is a typical thing if you read the literature. And what we did is we put 4,000 samples into this plot. So what do you see here? And this is something you immediately see that why this use the standard mud gas to make this prediction is quite suspicious in a way, and because the accuracy is rather low. Our machine learning model shows the fluid typing, the correctness is just 50%. Basically, you don't really know. And so we took the same approach. We look at the C1 to C3 from the standard mud gas, and we compare with the ground truth answer where we have this 4,000 PVT samples. And then we start to find something. And this is the one like very much like all the samples, but we define the fluid type 1, and we start to have a very clear disconnect between the gas and oil. And then you can tailor-made this threshold, the cutoff, to define the oil and the gas. And then you can make a really good prediction. But the first one, you need to know if your reservoir belongs to this type 1 or not. Because if you're in a type 2, sorry that this is something that if you only look at the C1, C2, that will not help. This is similar with other parameters because the most important, the most reliable one is only C1, 3 components. Compared with advanced mud gas, you have 7 components. So you don't expect you get the same information from 3 components. And this is what we do. And before I read all the text, and you can look at these bubbles. And we have a 5,000 wells drill on the Norwegian continental shelf, our standard mud gas. Even our project is a big success in our company, and we're really ramping up how many wells we use advanced one. But that's a small number. It's a small bubble here. This really indicates how important to extract the useful information from standard mud gas. So we developed a method in-house. We can actually do the correction using our software for the C1 to C3. For the water-based mud, you don't need very much correction, but for the oil-based mud, you need the correction. Otherwise, will be wrong. I will show you the example. And if you're lucky, you're in a type 1 reservoir with the couple with our correction, you can actually do a quite accurate prediction about the fluid typing, and it's more than 90%. So I will show you the example. And we already implemented in quite many wells because the standard mud gas is available everywhere. So if you can help people, and this is a very straightforward and it's really, really impactful. And we do have a plan for the type 2 reservoir, and we're working with all the vendors to really provide the heated degasser. And so in the next 1 or 2 years, that we really want to improve the correction method for the C1 to C5. So in a way, we can actually do some work, not as good as advanced mud gas, but much better than what we have today. And this example showing at how we actually manage this one. And this is a field. They have a lot of wells, exploration well and appraisal wells, and they just simply don't want to spend more money on the advanced mud gas. They push us very hard. They said, okay, if you give a solution on a standard mud gas, then we'll go for it. And luckily, we find a solution. And this field also belongs to the fluid type 1. And we gave them close to 100% accuracy on the fluid typing. And I will just show you 2 examples. This is the first one. This is during the exploration and water-based mud. And we didn't apply any correction. And these are the gamma resistivity and neutron and density. And this is CPI. You see the green one. This is where the hydrocarbon lays. So this is where all our gas and oil. And we took 4 PVT samples actually from this, 1 from the gas cap and 3 from the oil lag. These are the one already know. But this is one is free. It's in our hand for so long time, we never really seriously look at it. This is the data from the standard mud gas drilling. We get a very high total gas response here. And if you look at the traditional geochemistry parameters, C1, C2, C1, C3, Bernard, look at these black dots. They're the PVT samples. And you have the gas cap here, and you have the oil lag. And the PVT sample we took are just line thickness consistency if you compare with the, the mud gas. This is really amazing. And now I show you another example for the production well. And then I will show you a little bit about the correction we did here, because this is all the production well they deal with oil-based mud. And the solid one is the average value for the standard mud gas for the C1 content. And the dash one, the dotted one is after the correction. You see that when we do the correction and we start to get more C3 and reduced C1 and C2, they both reduce to the same direction. You still keep a very good divide between the gas and oil for the C1 and C2. And for the C3, the improvement is a lot. And you see the gas that we improve here for the oil, it just switch very much towards the right. And I will show you how this actually can help the fluid typing. Again, this is our reservoir, and now they are treating into the oil zone. And this is the well horizontal, and this is the oil zone. And if you look at the standard mud gas data, and without correction, and then you start to flip around, and gas and oil, oil gas, and for the C1, C3, very much like a gas. And Bernard, you show a mixture pictures, and it's hard for people to tell this is oil or gas. And after the correction, if you look at the C1, C2, everywhere is oil, everywhere is gas, everywhere is oil, everywhere is oil. All these parameters give you the same direction. And we went through more than 20 wells, and in both the water-based mud and oil-based mud. And the result is just so good that we actually made a tailor-made display for our people that from this field, and now they can use it for the later drilling. Okay. When you develop a technology or anybody, and there is always limitations, and same for this technology. And if you have a dry gas, very dry gas, you have a biodegradable fluid, or you have a heavy oil, and there is limitations because if you think about the information we use for all this work, and it's very much C1 to C5 or C1 to C3. If you have a dry gas or biodegradable fluid and you end up with very much only C1, and the other two become much smaller. So it's difficult to actually work on that system. And also, if you look at the GC that we use in advanced mud gas or the standard mud gas, they use air as a carry gas. So when they use air, they have CO2 in the air, and that's why if you look at our composition, we don't have CO2. And if you have CO2 field with a gas field with a lot of CO2, this is not working very well. And we don't suggest people take our GOR prediction. Even I show an example that we have a very close to the PVT sample, but you know that the machine learning model and we're in a band about plus minus 30 to 40%. So that's the accuracy we're talking about. And the good thing is after the drilling, and you will start to get more data. So you can always improve the accuracy on the fluid side. And we run a machine learning model, and instead of only feeding the C1 to C5, we feed in the density, and then our accuracy for the GOR just drop from 40 to 10. So in a way, when you have more data, so this prediction can be improved. Another thing is the model stability. And when you use, we use a PVT database to train the model, generate something we use, but our input data is not PVT composition. It's actually composition from advanced mud gas. And the nature of the data is more noisy. And when you train the model, and if they're all proportion, and then you get a good prediction. But when you feed in something are quite different than the PVT samples, and you might have some very strange predictions. And the last one is you can't expect this thing is working all the time because you know the drilling is complicated. It's never, if you look at the well schedule, and they're changing all the time. There's a lot of events, and by just you know, you want to drill through the reservoir more or less at a perfect speed and without stopping, and then you have a best data. But that just not always happen. And this is the conclusions. And I show you that we did something on the mud gas, and which are really a good source of data, and we start to really enjoy to use the data now. This is a new solution, and to identify gas and oil well drilling, and generate a lot of values for the well decision, real-time well decisions. And we work very closely with the vendors, and I think the industry are really good, and we're happy that they adapt so quickly that we're really doing real-time services now instead of before most well we get as post-well data. And now the mud logging is not only for the geochemists, and a lot of petroleum engineers are in place now, and basically we have a much expanded user group for the mud logging data. And the last point is the standard mud gas. They're mainly for the fluid typing, tell you the gas and oil. And using the method we mentioned, you have a good luck, you can get some really accurate fluid typing. And for the advanced mud gas data, that's something you can provide more, provide GOR density, and this is something you pay more, you get more, okay? And this is the last slide. And want to appreciate the management support from Equinor, and they did support this project very, very nicely. And we actually appreciate very much for that. At least some of my colleagues' name here, and I would say there's a lot of more than what I listed here. And this project is a really cross-discipline project, and I appreciate a lot of help from the geochemistry domain and the petrophysics domain. These people, our colleague, give us so much support. Otherwise, it's not possible to do this work. And if you want to know more details about the technology, I list some paper number here. You can find and you can read. You can always contact us if you have questions. Okay, so I will stop here, and thank you very much for your attention.
Thank you, Tao. This was great. A very good overview and something for everyone for sure. I got a few questions here from many angles, actually. Just clarify one thing first, the definition of a type 1 and type 2 reservoir, and if you can repeat that, because that's something I've gotten a few questions of in the chat from different people and also here in the Q&A session.
Yes, and I think this is something that both we and the industry maybe should look a little bit more into it. And when we show this result to our colleague, and of course the geochemist people start to question about when this actually the fluid will belong to the type 1, when they will become type 2, and how to handle this. And so what we have done is we get individual requests from our people, and we have a database already established. So we can do a quick analysis based on the PVT samples we have. We can very easily tell people they belong to the type 1 and type 2. And especially now, the industry shifted very much focus to the production. And when you're really working on the some age field with a lot of wells, and so in a way that you know a lot of information already, you can basically decide this is a 1 or 2. The challenge is if you drill into a prospect or something that you don't have a lot of data with, and then I think this will be a really challenge to tell is this type 2 or type 1, because you're making some decisions based on that split. The threshold we use are all tailor-made. They're specific to the field or the basin. And so we sort of gave up something. In a way, the approach we take is not very predictive. You can't really go to you drill a well and you have a no neighbor information. And then you ask, do I belong to type 1 or type 2? This is a more difficult to answer. We gave up that one, so we focus on that. We know a lot about this field already. We know it's belong to type 1 or type 2. And then what we achieve is we actually get the accuracy increase from 50% all the way down, all the way up to close to 100%. So this is a trade-off here. And I would think that if people dig more into this, especially my colleague and maybe some other smart people working in this domain, and you maybe possible to get a more like a predictive thing. You can tell people in advance that you belong to this one or another one.
Right, and you mentioned now like that you have big internal databases, probably some internal solutions and whatnot, Tao. But there's a question here with regards to just kind of tools related to this technology. Is there any software technology made available outside of Equinor in some way that's either commercially or through open source possible to access?
This is a very good question, and we are definitely open for this. And when we have this innovation here at this is a company decision, they want to actually patent this. And we don't really want to sell this technology, and because we're we basically want to have a freedom of operation, and we don't like a certain specific vendor. They 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 actually own this technology. So that's the whole logic behind it. So on in a way that we work with all the vendors that we have, and we are actually doing a lot of real-time support with Schlumberger, Baker Hughes, and Halliburton. We work them very much, and they actually see the software we use, and we are open for any collaboration in the future, because we might not charge anything. We can share something with the vendors, so makes this more general available for the industry. So far that we have all the papers. We're just not patent that. We actually publish all the details. So you can easily review the model, and based on the paper that we actually publish. But of course, coding the software and make it more testing and reliable, that will take some time. So I think if your company is having a collaboration agreement with us, and just like in many of the field in Norwegian continental shelf, and company and company, they can work together, and so we can actually share this with our partners as well. So this is not something really we want to keep. We want everybody to use it, and we want everybody have a fire opportunity, have a free operation, low cost, and this is something we want to promote.
Excellent. So that was a couple of questions, a little bit more on the broad sense. So when it comes to the data itself, can you, for production wells, if you like, if you have this type of data and analysis conducted for that particular well, can you reduce and save costs on any other data types collected for the wells when you have this advanced mud gas analysis there, or just a standard analysis with this these methods? And can you come up with some examples of that?
Yes, and it's possible. And we've been, I would say the current data acquisition already very, very lean. And if you have the gamma resistivity and nutrient density, and this is quite a lean program. And if we have this data side by side with our data, we feel a lot more comfortable to make the predictions, to interpret the result. So of course, we get real cases, and people drill into the 6-inch reservoir. They don't have nutrient density. They basically squeeze us. You're the only one now. Tell us. This is the gas and oil. So we have done that for multiple wells, and additional one, we get a lot of more requests now for the mud gas service. Is in overburden, and in the overburden, that the caliber is very big, so you can't couple that nutrient density. You don't have the possibility there. So we've been caught by many people just doing this mud gas analysis in overburden, and this is really important for the drilling and well. They want to know, actually, they really don't want to see a lot of gas there. So this is very important for the safety. And so this is we're working not only in reservoir, we're working with the overburden. This really come to your question. So basically, we just been challenged by people, and actually, in some cases, we already start a service and replacing some of the tools that we almost define as the minimal. So we start to some of the wells we have done, they already below the minimal data acquisition, and that's a real business case. And this is I hope this answers your question.
Yeah, that's perfect. The going even more into the details here, it's a question about kind of the mud gas response. So if you had different processes for different mud types, there's a question related to that. So we've noticed that brine mud has quite different mud gas response than invert. Personally, full transparency, I don't know even what invert is, but maybe you do there, Tom.
Yeah, the mud type, and if you use advanced mud gas, and according to our service vendors, that the full correction from the vendor, that you get almost irrelevant if you use like the water-based mud or the oil-based mud. As I show you that in the standard mud gas, and because the data is raw data, there is no correction because you pay more to the vendor, and you get a lot of service there. You get a recycle correction, you get the EEC correction, and you get actually 2 degassers for the advanced mud gas service. And in the standard one, it's only 1 degasser and raw data. And then you need to work on that yourself then. So, and then the water-based mud and oil-based mud, and it's very different. And another bad thing that we experience is the driller don't really tell you exactly. They told us that this is a water-based mud, and and when we actually look at the composition, and there's a lot of glycols, alcohols, just mask everything, and you can't really read the composition. It's not always mean water-based mud is okay, you will get a high quality data, but not always, because of the mud, it's been through so many wells. There's so many additives in it, and maybe not documented. When we go back to the mud provider, and they said no, nothing special, everything is right, but when you look at the composition, that is not. It's difficult sometimes.
Yeah, for sure. Going even further kind of into the data, you talked a lot about kind of the differences between standard mud gas and an advanced mud gas. And I think you kind of dropped some percentage numbers in terms of relative error that you can expect.
Yes.
The two questions related to that. Have you tested the raw samples of just advanced mud gas with just standard? And do you see like on a relative basis how much that increase is?
Well, it's if you don't do correction, and basically our advice is don't use it, because our machine learning model heavily depending on the C4, C5. And the C4, C5 from the standard mud gas are in the ppm range, and it's really uncertain and masked by a lot of things. And you don't want to trust your model based on that. And even the method we propose in this presentation for the standard mud gas is only limited to fluid typing. You tell this is oil, this is gas. We don't tell you the gas oil ratio. We don't tell you exactly what is the density. Yeah. If you need that information, then you need to order advanced service.
So I think we'll have time for two more questions. This one is related to kind of what you try to fit, and one of the things you're talking a lot about is GOR, and then you're kind of correlating that to some either a wetness ratio or some kind of compositional ratio, where so you're comparing something that is a state function, so a path-dependent property like GOR, versus something that's not. Can you elaborate what you've done to that GOR value? Have you processed or reprocessed that through some kind of common process or a standard facility? Or what are you doing with just to make that GOR value on the y-axis consistent?
Yes, and since our accuracy is quite kind of a you know it's not as good as from the PVT lab, so we don't limit ourselves to the process station, the process conditions. So we very much actually use is a single flash here. So we don't feel, because the reason we use a single flash is a lot of data, they have only single flash, okay? And of course you can do some, you can correct it to the common conditions. We didn't do that. We use the raw data directly, and also we know that our limitation on the accuracy, so we don't feel that it's already masked by your model there. And when we look into the impact for which one actually plays most to impact the GOR in the machine learning model, and we put the standard the geochemistry parameters like wetness and other combination of the ratios, and the machine learning model, when we did the work, they came out actually it's a surprising. It just use C1, C2, just the absolute input. That's actually giving the best result instead of using any ratios. And that's a surprise. And I guess this is also depending on your model, which model you use, and the selection of the features. That's the data engineer called. The features are related with the model you use. And for our model, like random forest and Gaussian regression, and we find the best way just put the 7 parameters there as raw data, and they gave us the best result. So no other combination actually override that one. So, but still, the 7 component, they have a different weighting if you look at the final result. That's why I mentioned this C4, C5. The C4, C5 is very important actually for the GOR prediction. Of course, the C1. So you have the high weighting on the features, the C1 and C4, C5. These are the one tell you that you are.
Okay, very nice. So one last question that will be just a question to round off this. You know, the last, I guess, decade, or at least over the last 5 years, we've heard a lot of things about artificial intelligence and machine learning in and outside of the oil and gas industry or the energy space in general. So I guess the question is, you know, when your group and the people that you're working with internally in Equinor are, you know, developing all these machine learning tools and methodologies, is it easy to explain to other people and users and also people that need to trust these results to trust those models when there's so many things to pick from and maybe they don't know necessarily all the details of these models?
This is the communication. So communication is very important. That you know, when we do the modeling work, and we're sitting very close to the data group and the data engineers, and they have a limited background about the petroleum technology, and we're the one you call the SME, subject matter expert. We have a very close collaboration with the data scientist. So this is I would think this is the only way can make sure your project fly. And you can't just give your data and tell what you want and then let the data engineer they flip the model by themselves. So you need to really have a very close ties with them because it's always a decision about to make how to run the project in the middle. So this is very important that you keep a high level communication with the people working on it, especially the data engineers. And come to the second part, I would think if you come to the user group, and you want to make things as simple as possible. You don't want to show all these fancy models, even the name, and you want to make it very generic and easy to understand. And our people, otherwise, it's hard to actually give a tool which are so complex and to the people. We actually made the software in our company at different the complexity levels. So we have the expert group. They have a full version with all the features you want to look at it. You're not only look at the prediction, the QC, how the data is good, what is the result. We want to compare all the polygons and all these details. And we want to run not only GUR, we want to run the density, the saturation pressure, the full package. We have a paper on that. You can run all of that. So on another hand, we give our people in a real operation, real-time operation in a GOC, Geo Operation Center, and we give them a tool with only several columns there. They have the raw data, they have the quality, and they have the prediction, no more. So this is important because the communication is very important towards the targets. And if we make a full version towards because they're very busy and on a duty and they have so many screens they have to look at it, and you don't want to give them too much work there, and should give the most important and help them to make the decision, and also flag out the issues. And when we have the QC flag out the issues, they call, and our people also on duty, we help them to find out the solution. Hope this answers your question regarding the communication.
Yeah, perfect, perfect. So I think that's a nice place to round off. There's still some unanswered questions. I'm sure Tal will be happy to answer some of those over email or when you see him in person at the next either virtual or I guess in-person conference. So with that, thank you again, Tal, for the time and great presentation and Q&A session. Thanks for all the good questions and thanks for attending.
Thank you.